now on to the actual homework here. Alright, graph the functions, complete the table, round values to the nearest tenth, and use the transformation ideas talked about in class. Do not forget to state the domain, range, and equation for the horizontal asymptote. We have 4 to the x. Your mom here, your mom function, is going to be y equals a times b to the x, and it is growth, because that's a 4, so it's going to look something like this. Now, there are no real transformations. There aren't any. I don't see any. So we're just going to make a small table, maybe a 0, a 1, and a 2, and a 2 will probably do it. If you plug in a 0, this would be 4 to the 0, which is by definition 1. This is 4 to the first, which is 4, and this is 4 squared, which is 16. So we contain the point 0, 1. We contain the point 1, 4. And then we contain 2, 16, which is way up here. Now, you do have to remember that mom flatlines near the y-axis, or sorry, the x-axis. This thing hasn't been shifted left or right any, so there she is. Her domain, she runs left forever, she runs right forever. Her range, she gets close to 0, but she never actually hits 0, and then she rises to infinity as you move right. And the horizontal asymptote is this line right here, the x-axis, which is y equals 0. Ta-da! Alright, moving forward. Not too far. Number 3, graph this one. Let me write this down so I have room to talk about the transformations. By the way, you cannot multiply the 4 and the 1/4 together because of the exponential space right there. What do we have here? We have that x minus 2. That is a right 2. We have the plus 2, which is up 2. Those are your transformations. So we're going to go right 2. And we're going to go up 2. And then we're going to plug some crap in. That's what we're going to do. Is that red? Okay, that's red. I'm going to plug in a here, right here, 2. And I'm going to plug in a 3, and I'm going to plug in a 4. If I plug in a 2, f of 2 is a quarter times 4 to the 2 minus 2 plus 2. That's a quarter of 4 to the 0 plus 2. 4 to the 0 is 1. So I have a quarter of 1 plus 2. And this is 2 1/4. Or 2.25, whatever you like. If I plug in a 3, I ought to get a whole number. I should anyways. So f of 3 is a quarter of 4 to the 3 minus 2 plus 2. That's going to be 4 to the first, which is 4. Quarter of 4 is 1, plus 2 is 3. And I'm going to get a decimal when I plug in a 4. Or will I? No, I'll get a whole number. F of 4 is going to be a quarter of 4. 4 minus 2 is 2, plus 2. That's 16, 6. And there's my 3 points. So we have 2 and then 2.25. It's going to be kind of hard to do. Somewhere in there. 3, 3. And then 4, 6. And we're going to flatline near this asymptote. Flatline at the horizontal asymptote, which is that guy right there, because it's horizontal. All exponential functions have a domain of negative infinity to infinity. This one's range, we have a low value really close to 2, and then we rise forever. And our horizontal asymptote is right here, which is y equals 2, right there. So, there we go. There's number 3. If your ancestor invested a penny on January 1st, 1776 at 10% interest yearly, how much would you have on January 1st, 2025, assuming you are the sole beneficiary? Quite a bit of money. All right, so we're going to use this form here. Y equals, sorry, not Y. The amount after time passes is the principal times 1 plus R to the T. All right, the principal here is a penny, so $0.01. The rate of interest is 10%, which is 0.10. And time is going to be 2025 minus 1776, which is quite a few years. What is it, 249 years? Seems legit. You're going to have a lot of money. I need to pause this real quick so I can get a piece of software